So we have done it with the milk in Bayern and Baden-Württemberg, and now we go for a summary of what we have done last week. You guys have now a short view on the exercise. So last time, if you remember, after introduction to spatial data analysis, we have learned about the spatial weight matrix. We have learned about the Moran I test. We have learned about the spatial regressions and taxonomy of spatial regression models with the emphasis on SEM and SAR. And we have gone to some mathematical foundation of these two regressions last time. Here is the answer to Albert Dudo. Yeah, so you see we had a rho and lambda. They have an absolute value, so they could be negative or positive. We discussed that last time. And yeah, so we've gone through the two models, and then we have learned about the coordinates and UTM. We have learned about the basics of R. We get to know about the spatial objects, mapping, weight matrix. Then we have gone for the spatial regressions in R. And we have distributed the exercises between two groups that one could today present their work. Was very nice, well done on the short time, and back to the knowledge that we have in 6.5 hours teaching last time. Well done. So this was the summary of last session. So these are some books that you people can go to work on spatial statistics and spatial econometrics in R. Especially the one in the middle is very good, well written, well explained, good examples. I advise this one if you are more fascinated. But the one with the bvand, they are more into R-ing and to putting maps and points, coordinates, everything. And the one on the left, the applied spatial statistics and econometrics, is very comprehensive, has many staff, many things there. And I have used these books for our presentation last time and this time. So today we start with some case studies. I have prepared 3 case studies, the application of the spatial regressions, and then we go to the issues rows on the topic of the spatial econometrics in the recent years, and I will discuss some of them for those who want to do research in the near future. So I just check with the technical groups if everything is okay. So let me see if everybody have this. Yes, everything is fine. Sound and picture is there. Okay, so we go to the first studies. One of the basic studies on application of the spatial econometrics to hedonic valuation. So hedonic pricing or hedonic valuation, if you are familiar with that, we have a price of something which has some attributes, and we want to see what is the value of attributes in the total value of that commodity. In this case, here in Greece, this study has been done in 2008, and they have analyzed the value of irrigation water by considering the price of agricultural land. So, like there were like 17,000 parcels of land there. So they have checked who has traded them, and then they have used that price of the traded parcels, considering the size of parcel and some geographical values, and they run the regressions. So they wanted to find the value of the irrigation water as a characteristic, so quota assigned to each parcel, and they have considered the 1,517 land parcels, and then more geographical variable considered in this paper than the socioeconomic variables. I think because basically they couldn't find anything on the seller and so on. They have tested the OLS and the SAR and SEM as Yannick and Team 2 has done, and they reached to a conclusion that SEM is the preferred model, special error model. So lambda, with the one with the lambda, not with the rho. So the next study is from the core, a very recent one, the core of the Agriculture Economics Journal, American Journal of Agriculture Economics, published on the productivity in Italy in agriculture area. And just a moment, I just write something. And in this setting, in this analysis, they have tried to see if the by using the farm level data, they wanted to see if the total factor productivity, which is something we measure very much in the field of agriculture economics, shows some dependency at the aggregated level of the NOT3 region. Yeah, so they have used FADN farm level data, which is a survey run in European Union on the farms between 2008 and 2015, and then they have aggregated the total factor productivity data at the level of the NOTS3, so municipalities, as we have seen in the Baden-Württemberg, and they applied the SEM on the total factor productivity. Results? Yeah, they found, they developed 3 different index of total factor productivity, and they found they have used the Bayesian approach, yeah, not the simple frequentist or normal conventional OLS, but Bayesian one. I hope everybody heard about the Bayesian approach, so I don't explain it here. So, but as you can say, is different philosophy and estimation of the regressions. So we consider prior probabilities of the coefficients, and then we reach to a posterior. So in this approach, these guys, they found a sort of a fast, not long-term, fast spillover effect of the productivity between the neighboring municipalities. So, any question till now on these 2 studies? No question? Good. So I now break a bit harder one study done in Iran newly, and even one of the authors, co-authors, is a friend of mine, but I have found some fascinating discussion with you people, and I hope that you guys in chat will cooperate with me to go through this paper. So this paper, we will just break it down to knees, and we will see what could be a problem here. So paper is about the effects of water conservation policies on groundwater depletion in Iran, and the goal is to investigate this. So conservation policy on the groundwater depletion. So these guys, they have worked on the provincial level, yeah, but with the panel data. So cross-sectional data of the groundwater extraction minus groundwater recharge at the level of the province is gathered, and then it is regressed on some variables. So they want to see if what they call the conservation policies has an effect on the size of the groundwater depletion from their points of view, the difference between the recharge and the extraction. So, as I said, the dependent variable is difference between the yearly extraction of the water from the aquifers, groundwater resources, aquifer, we call it. So, in German, they say Grundwasserleiter for the German speakers. So, Grundwasserleiter or aquifer. It's like a pot in the ground that water is among the soils and the rocks there, and we extract them with the wells. So the panel data is constructed based on the available data on 31 provinces, yeah, from 2010 to 2016. And they said the conservation policy is the price increase. Moran I test is tested that you see down, and then they run the SAR, SEM, and SAC I have presented as a Kelly-Khan-Purusha model last time. So you guys see the Moran I test and two similar tests that I told you last time that are available. I want to see in chat what is your interpretation of these coefficients, guys. Ladies and gentlemen, what do you think about the results of the Moran I test and two other special tests on the regression? Yannick is writing. Yannick said Moran I test at 10% level is significant. Yeah? So Moran I test at 10% significant. Is it enough to judge? Is it enough to judge? Any other idea? Any other person? People from Iran? Do you say anything about this Moran I test and the two other tests? What do you think? Do you see that we should somehow firmly and strongly say we have a special autocorrelation? Albert tried something. Right. The special dependency is weak. It means that it's hard to claim, really. Yeah? Hard to claim. And if probably here, if we do an OLS, nobody can accuse us. This is my interpretation of these results. So we go further. The result of one special autoregression model you can see here, and as you see, they have considered the number of shallow wells, number of deep wells, number of canals. Canals is a subterranean tunnel that is traditionally used in Iran to transfer water from a deep sources after kilometers run back to the slope of the land and comes up over the ground some point. Much more environmentally friendly, much more useful, which somehow destructed the system, destructed with the wells in Iran. So cannot, they counted for number of canals, agricultural cultivated areas, area under modern irrigation, precipitation, temperature, population in the province, drought index, agricultural price index, cost of electricity, and constant. So, what do you interpret from this study, guys? So, they have run an SAR. SAR is 0.021, and SEM, the lambda is 0.012, not significant, and the rho is at the 10%. What do you think here? Yannick said the rho is at 10%. Yannick is not at the 5%. Look to the down. They have said you know the level of significance 5, 1, and so these guys, they have somehow a sort of very weak dependency. The rho is not at the you know 2 stars in this case is at 1%. So 1 star is at 5%. Yes, 5%. So 5% right. So rho at 5%, SEM not significant, and SAC, the Kelly-Khan-Purusha, it has both parameters significant. So what do you understand from the rho of 0.02 and 0.03? Nobody from Iran has an idea here on the rows? Guys, say something. Can you claim that if you extract groundwater in the one province, for example, Khorasan Razavi, then the extraction of water from groundwater will increase in the South Khorasan? Positively effective. So I think you people just miss one point. Is the magnitude of this rho is very weak. Yeah, the magnitude of rho is very weak, and that is in line with our Moran eye test. It was not strong. The rho's are low, no matter which model we do. I will tell why this has happened. Definitely, I think if we look to the provinces, we cannot claim that so easily. We cannot claim that if total groundwater extraction in one province increases or decreases, that will affect the one to the other provinces. And I will show why this is the case. So, do you see any other things? So they said the conservation policy they have considered is the cost of electricity. Do you think that is affecting this structure? What do you guys think? So the cost of electricity, look to the sign and look to the significance level. Those from Iran, what do you think? Do you think the price of electricity in the agriculture sector between 2010 and 2016 has increased so much that it has affected the level of the groundwater extraction? So think about that. We go further with that. So yeah, so I want you guys read the conclusion. They said that they found a special correlation in the groundwater depletion in different provinces. There is they have not count the Kanye response or Dini response. They have the contiguity. So they considered only the neighboring provinces as the affecting neighboring points on each province. Contiguity. We have discussed that in the Scotland and the Ireland and UK case. So a special correlation, the groundwater, they said they have found. The results indicate that the gradual removal of energy subsidies for agricultural activity is an effective policy to mitigate groundwater depletion. In Iran, where water depletion is a serious challenge, a small increase in energy price through the removal of energy subsidies would not lead to significant reverse in the water depletion. So you guys, we go back soon again to the same table. But do you agree with all these three conclusions? And what could be a replacing research instead of this to test the same hypothesis? I expect people from Iran to answer this question more. So they are more into the condition. I want to go on the nerve of colleagues a bit, and I just want to see what you people think about these results. You know, these guys are very, very bad lucky, because I, as a guy who worked on the water economics, groundwater economics for many years, and a spatial econometrician, I found this case study for this course. I brought it here to maybe go on the nerve of the colleagues a bit. So what do you guys think? What else here is fascinating except the cost of electricity price goes down? So people from Iran, what has happened between 2010 and 2016? Do you remember the major events that years? Yeah, you see, the spatial econometrics is not only putting the wet matrix to an OLS and that's it. You have to sit and interpret the coefficients. Yeah, okay. It seems that historical memory is not very strong. So I will say, at the beginning of this time period of a study here, 2010 to 16, we had a subsidy cut and direct payments. Yeah, so they call it in Persian طرح تحول قیمت‌ها. So it was at that year, I think it was December 2010, that a part of the subsidies for the oil and gas, electricity is cut, and after that we have a jump in the prices. People are paid directly. So each citizen receives a certain level of money at that year, which is continued till now. But at the same time, we have a jump in the other prices. Yeah, and that you can see in this graph. So if you go over the cost of electricity and look to the agriculture price index, you will see that it is not significant at the same time with the prices, but in this last model of SAC, it has a very strong, significant effect of the water extraction. Yeah, with the much higher values and much more than what they found as a cost of electricity. The cost of electricity for pumping sector in Iran first planned to be 10 times more in that plan, but it's very fastly adjusted and not really changed. But then the cost of commodities has increased much more than it makes much sense for people to continue to pump, especially in the agriculture sector, because the price of the agricultural product has increased heavily. And at the another thing, so 2009, the whole illegal wells are legalized by the Iranian parliament. Yeah, so the size of wells has dramatically jumped up, and as a result of that, there was like not much water left to be extracted. So it is not very clear to me that the reduction of the water extraction, yeah, between 2010 and 16, which I can show you in another graph, which I have developed for a book chapter I've written, is due to this minor price increase, or actually because there was no water left in the groundwater resources. So guys, be very careful when you interpret the results, because then you may find me reading your stuff for my econometric course, and then yes, I will find some bad conclusions. So I share my screen shortly with you people. I go shortly out from here and I share my screen. Yes. So do you guys have this this page? So somebody write in chat something so I can see. Mauricio said yes. So this is the number of wells actually increased. Yeah. So if you look to the 2010, after 2010, you will see the number of shallow wells and deep wells both are increasing. Yeah. And then the size of groundwater extraction, which is this line here, I write it. I try to write moment. Yeah. So this one. No. Just a moment. So do you guys see this one, these two lines? Do you see these two lines, guys? Yeah. So you see the total size of groundwater is decreased. Yeah. At the same time, this line here, it shows the electricity consumption is increased. The electricity consumption for the pumping is increased. The total water extraction is decreased. Yeah. And that is not because of the increase in a minor increase in the price of the energy in real, but it's because there is no water there. Yeah. That is my critique on this paper. So this paper is just neglected the issue that there was no water left, although the size of energy for pumping increased and the number of wells increased also. Any comments on this claim that I have given? So I have two critics on this. The first conclusion, I think that spatial autocorrelation is very weak. A second conclusion is that I don't see it, because at the same time, when the minor increase in the price for pumping is happened, then the price of the agricultural commodity has increased much more at the same time. And then it was making sense for people to continue to pumping more because they could sell at the higher prices. And this minor increase in the price of energy for agricultural sector was much less, and still is much less than the other sectors. So guys, be careful, not interpret so fast the result of a regression model. Yeah, I'm very sorry for these friends. I have not seen this paper if I have not forced to do this lecture with you people. So any question to me on breaking down this paper? One thing. These are the whole aquifers that we have in Iran. So there are like 609 aquifers, and this is the place that those guys, they could really come to an idea of the spatial autocorrelation. Not at the province level, but at the aquifer level. So aquifers, they are connected underground to each other. You can find many aquifers. They are not an isolated one. The groundwater is moving from the down of the earth from one aquifer to the other aquifer. So here, if they have found they found the data not at the province level, but at the county level. County, like 409 county we will work with this data of the counties later today. They would have probably seen much stronger rows there. Is anybody agree or disagree with me? I claim that that results could be different if the two researchers, those researchers there, they have not looked to the provincial data, but the county level data. Any comments? May I summarize something? Maybe, yes, maybe. I claim that this row in this paper, this rho and lambda, any of them, it could be much higher if they have looked not at the provincial level, but they have looked at. Mersad said yes. Mersad disagrees with me. So that's it. I hope you have enjoyed the 3 case studies I found from the different literature, and I have critically looked to one of them which I found maybe fascinating to be discussed today. So if there are any question on the case studies, if not, we go to some developments happened in the spatial econometrics in latest time. So these are 4 books I just presenting here, and I will discuss them, which are not older than 2020. So they are all from 2000 and 2020 and 2021. These are the hot discussions, the frontiers of the spatial econometrics. So we start with the first one, the spatial econometrics for resilience on climate and environmental shocks. As you have seen from the first part of the session 1, we had like a disruptive climate and environmental changes have a spatial propagation process. Yeah, so they are expanding sort of spatially. And that can affect the infrastructures, that can affect the economic units, economic systems. Yeah. So then we can conclude that by using this spatial econometrics, we can somehow improve the behavior of the economic system versus what comes as a shock. So understanding this process needs or is interesting with the spatial econometrics to improve the climate policy in view of a stronger mitigation and adaptation for those shocks we've discussed. So big data. Big data is another issue which appears and attracted the attention of some researchers. A digital revolution has created a tremendous data to be available through technologies such as Internet of Things, Internet itself, mobiles, different things you can't imagine. And spatial big data become available through Google Earth, as you've seen, through shapefiles, through different things. It's a dynamic ecosystem that we have here with the digital revolution. So demand for things like smart cities, environmental management, climate issues make it a higher demand for spatial econometrics to use the big data. So we need some adaptation here. If we use the big data, we need an adaptation to this model to do estimation, to do the prediction, to find the causalities. And this is a new hot area in this regard. So there are some issues with the estimation. We have a a spatial panel econometrics, where we think that, for example, look to the regions, to the paper that we had before on the Italy and Iran on total factor productivity. You have an event happens in a certain geographical area repeatedly. In this case, you can say, okay, I can have a sort of time series autoregressive structure or moving average structure in my data, that the data, same observation in the same place, take different values through the time. So I will apply a panel model. There only I consider the a spatial structure for my error. Yeah. But when I am dealing with the microdata, it could be the case that I have a certain microdata, census data, data with questionnaires. I could have the observation goes out from the regions, the special regions I have. They will change. They will not there anymore. So if you go look to the two panels I put here, on the left side, you have a structure of the spatial panel model that through the time, which you can see with the arrow on the left, through the time, you have observation in certain geographical regions which affecting another observation through the time. Yeah. So observation from older time in the same region can affect another observation in the later time. But if the observations start to move in the geographical region, we have a temporal-spatial structure. It means that in a certain time, we have a certain observation affecting one observation, but those observations may migrate to somewhere else. Yeah? So if I am a member of a census in Tehran in 2001, I am not there anymore. I am somewhere else and I'm not that observation in Tehran anymore. So what you will do, you have to do different models, and this happens too much with the data. So a spatio-temporal approach is developed by using the spatio-temporal autoregressive model. Question here? Did you people get the point? We had a panel. The observation are not in the geographical position anymore later. So we need to change our model, because that observation, which is a unit of a study in the certain area, has gone. Imagine in Germany, we had some people who were living in a region, and then flood has destroyed their life and they just migrate somewhere else. They are not there anymore. So the observation is gone. No question? Good. So this structure that you saw even become a serious thing for the econometrician, and they put the title of the spatial microeconometrics on it, and they divided the data to three groups, the three groups of microdata. One is what we are discussing in this lecture, and we have started last week. So we consider the observation is in a certain geographical unit, and it is exogenous to that. You know, so the geographical unit is exogenous to the observation. Clear? So if I am in Halle, I'm in Halle. I'm not moving out of Halle. I am in Halle, and when you are dealing with me as a microdata, as an observation, you can come to me and deal with me. I was in another city in Germany, and for 2 rounds of census, I was an observation in a house which was selected, in an apartment which was selected. But now I'm not there anymore. Yeah. So this structure of data is not what we're studying till now, and we will not study in this lecture, but this is an available situation with the spatial data. So you can have the observation, and you can assume the observation will not move. So when we use a regional data, geographical region, municipality data, village data, and so on, we are dealing with the static structure with the observation relation to the geographical unit. Yeah. But if the observation moves between the geographical units, we need to deal it with differently. So the statisticians have come up with one dynamic process. So they they consider the movement of the economic unit, if we call economic units, as a process, and they consider the choice of agent to go into a geographical unit as a core of their study. So it is not the spatial units here, but the choice of the economic agents where to go. And then there are people to put it together, and they have considered two things at the same time, modeling both a spatial location choice and the spatial behavior of the economic agent. Location choice of the economic agents and the joint locations with respect to other agents. So what we have discussed, and many spatial econometricians and all the studies I have presented here, we consider a static relation between the observation and the geographical region. But this is not the case with microdata all the time, and there are data which are not stable and they move. So you need different type of spatial microeconometrics models to deal with them. Question with that? But I want to emphasize that again today. Yeah. We have a spatial object. It can be a point, it can be a line, it can be a polygon, it can be a grid. Yeah. In order to do a spatial econometrics, that spatial object has to be translated to the neighbor list, and from neighbor list it has to be translated to the spatial weight matrix. Our friends, group 2, who work on the milk in Baden-Württemberg and Bayern, they thought the spatial object is only a shapefile, and that was a mistake. The spatial object can be a point, and point, I told you last time, point is the place that we need to put the weight matrix on. So we can do without any plotting, without any mapping, we can run our spatial econometric model if we have only the point that the observations have. Yeah, so we have cell to neighbors, grids to neighbors, car-nearest point to neighbors, and polygons to neighbors. These are the functions in SDEP, spatial dependence package in R. So these are the functions which transferring different objects to the neighbor list. And then through the NB2 list weight, we move from the neighbors to the weight matrix. This was, I've done it very fast last time, very sorry, but that was the shortage of time. Today we will stay and we will test them deep and deep up to the knees. Today we will do that. Very important things to all participants. We have a website which called rsic.org. I want to show you how this website works. So please, in Google or in Fox from somewhere in your Explorer, write rsic.org. I stop the sharing here at this point with this part, and I share my screen. So guys, do you have my screen? Do you have the rsic.org on my screen? Some yes I need. Right. So we go to this and we say spatial econometrics. Yes? Enter. Look for guys what we have. We have all means the whole category of research com, and we have things from the R projects, so from the official website, from Wikidata, Wikipedia, from the special part of the R, we have then documentation, we have issues, we have GitHubs, we have econometrics, we have packages, we have blogs, we have everything. You see, R is working with the RSig. Guys, we start with some hand warming. It is now 10:42. We start with some hand warming. So we will create a sort of data set by the help of a library which is called DPLYR. Is everybody there? If everybody has DPLYR, like just run it and put these codes there. DPLYR, one conflicts false. Run. Mauricio said yes. Yes. So everybody run. And then we will make a vector. Yeah, a vector. And then we assign the values to the second vector. So we could define a vector of D like this. So we run it. If you say here data, you see, you have 4 values. Agree, strongly agree, disagree, agree, disagree, strongly agree. You have it? Mauricio, you have it? Yes. Good. Now we assign some values to the same vector to do the recode. Yeah, we do a bit of recoding. We say data, so the same thing we had, we mutate the list of variables and we put a value to each one, a sort of list of value. So guys, consider that this sign here, percent, bigger percent. Yeah, this is assigning something to something else. Very important. Now we write in the R again. Look, we write data here. Yes, we have a value added as a second vector. You see? Error in load namespace. Mauricio, you have made a problem probably. Do it again. Yannick, do you have the same problem as Mauricio? Annika, do you have the same problem as Mauricio? Masa, have you got it? Do you have this package, Mauricio? This package, you look. This, I put it in the chat. Do you have this package? If you don't have the package, then leave it. So, did you install the package? I mean, install not, no, like activated the package. If activated the package, then it should work. I don't know why it doesn't work for you. So I had the code here for you guys. You can run it and you will see. So I assigned the second variable to it with the $. Yeah, things change. Now I use the $. Look, $. Yeah, data. You see the second vector we've added. The first vector I have used with this strange sign here. What is said by Mauricio? Mauricio, error in loading. No idea, man, what's going on with you. So, but you just look at that. You don't need really. You can test it with a simpler thing later, or you have to find what's going on wrong there. I don't know. So we have a matrix now. Look, people, we have a matrix. I just kill in this the area again. They're here. Look, a matrix of 3 columns. Yeah. Data I have created now. One is, don't forget, very important. If you look to the up case here, it said it is a character, and the other one is a double. Double an integer. Double means it can have a decimal, and integer means it doesn't. Yeah. So I define it as a data. So as data frame, yeah, here we test something. We say class data. Yeah, we run it. Class. So it gave us something as a data frame. Yeah, but if something is not a data frame, we can define it as a data frame like this. Yeah, like this. And then we check the class again. str, a string, yeah, data. We check it. What is this? It said we have a characters and numbers. Yeah, characters and numbers. So when we want to check the inside an object, this is two things we use: class and str, and names. Names is another thing. Look, guys, write names. Yeah, data. Three variables name. Yeah, if you look to the data set, you see we have these names: variable R and variable R2. So now we do something else. We define that as a matrix. So we don't remember last time we have made a matrix with hand in the basics last time. I can bring it actually. I can bring it. We can have a look. The matrix last time we have the matrix I made. Yeah, here. I just copy paste it. Let's do it like this. Yeah, here. That's it. So you remember we had a matrix last time. We can play with the same matrix as last time also. So for Mauricio, who is a bit not working with this, Mauricio, you can take these codes, put it in the R, and work that. I put the codes in the chat. Yeah, so that, you see, M is a matrix. The other one is also matrix, but the other one was not matrix. I forced it to be a matrix. Yeah, you're welcome. You're welcome, Mauricio. So as matrix as data, yeah, that's it. Now look, guys, magic. We do a transpose. You remember transpose we were working? If we put T at the beginning and print is open, and then as matrix in, print is closed, then we transpose it. Yes, amazing. So I have tried to work with the library mathlib. Yeah, I couldn't implement for a strange reason the inverse version, but the reason was mainly because I didn't have a numerical matrix. So imagine we have a numerical matrix M. Everybody implement the codes I have given. It's numerically singular. So we say in this here 2, 6, 1, and 3. We change the numbers in that. We implement M like this. Yes, please change the numbers, and we check the inverse of the M. Numerically singular. Somehow it doesn't take it. Yeah, the point what I want to bring here is we need a bigger matrices than 2 by 2, but these codes you can use to have an inverse matrix, or you can have the if everything is numeric, you can have a transpose matrix. So yeah, so solve inverse. Yeah, these codes I given here, they are working for doing that, and it doesn't work when it is not a number. So because the main matrix we had here, it has some characters inside, agree, disagree, then we cannot go for that. We can do something here. We can make it as a mm, we say as data equal to, so we assign a new object of mm as data, and then we say we only want the two final columns. Yeah, two final columns. Yes. I don't know, Yannick, this question. I need a bit think a bit. But let's check it with the different matrix. So I have selected people the column 2 and 3 of this first matrix that we defined. So we just go to that, look, we have only 2. And now we do the inverse of m. Let's see if we can. Oh, that's we can again. 2 and 3, we say we want row 1 to 3. So we have a now 3 by 3 matrix. No, still not. I don't think this will work here. We just test the transpose again. Yes, so transpose works, and inverse should work also. I don't know why inverse doesn't. Does it need a T? Like T, M? Let's see. No. Inverse M to inverse M. Thank you, thank you, thank you. No, it didn't react. Inverse M. Let's see. Must be a square numeric matrix. We have something. So I think the data we have give us a singularity, so we cannot take the inverse matrix. We need to have a better matrix, I think. Yes, the problem is the singularity of these two matrices. So the mm that we defined here, look, this is singular matrix. So if it is not a singular matrix, m is a singular matrix. So if the result is not inversible. But just wanted to tell you that inverse is like this, so it works like that. So everybody is here. Everybody has played a bit with the matrices and the data. If yes, we want to go back to our fun of the mapping. Ready? Fun of the mapping. Does everybody has my screen? Everything is working? Yannick, do you have the screen? Alberto has the screen. Annika has everything is fine. Okay. In Iran, everything is fine. Masa, do you have everything? Do you see everything? Albert, do you have everything? Zahra has it. Good. So, library map data. People run it 2 times. Look, anytime you run a library, yeah, the first time if you receive a strange message, run it again and you will see nothing. So we saw one message that one more things is needed. So this map data has many data in it. I leave it for you guys to explore it yourself. But here we do the first mapping. Look, who has the nice map of Germany without any line in? Yannick, do you have the map? Mauricio has it. Perfect. So now we go for the Iran map. So yes, mapping is ready to go. So guys, we need to have these 3 packages installed now. Not installed, activated. I hope everybody has installed it before. You see, we receive some additional messages. We run it again. We get rid of them. Everybody had the 3 passage Mac packages installed. Perfect. So again, we go to the nice map shapefile from the lovely organization of the BKG, which is so nice to put the maps available to everybody. So guys, we need this one. We need NOTS 3 250. You have already it yesterday, the files. Go to the path, install the path. The path installed. I hope everybody have it. The path is taken. Yeah, you should have your path, the place that you put this shapefile in. Oh, sorry, Mastume. Why not? Oh, okay. Try to in the lunch break, try to install that list of the packages I send around. Maybe you can work with us after the lunch. So, people, look, the path I have taught to you yesterday how to put these shape files in a certain place. I hope everybody has done it. And now we need this one, UTM NOTS 3. Yeah, not 1. Look to the last part of the file, that's NOTS 3. We need this file. Everybody have it? Yannick said. Can you maybe show the Iranian participants how to download the packages? Not possible to in Iran. Okay. So, imagine you are going to install a package. Package which you want to install should come from a CRAN. People, only Austria. Other people, you are not sure, they have the latest version. Select the Austria. This is the core theme of R. You have the mirror, you see, choose the mirror is appeared. Now you go and install the package that you like. The package that I already have, but for example, map tools. You go to the map tools here, look, went based on the alphabetical order. You said map tools here. Yeah, you get okay. Because I have already installed, it doesn't give me and then another way is to use these codes. Yeah, you will use these codes. Install package dependence true. Let me, I had it somewhere. Yeah, so you don't need really to write the dependence true, but it's a good way. So here, the second way, you write this, the second way to install package. So when you say install package map data here, you put it, it doesn't give me, but if it's not installed, then it asks you to select the CRAN, you select Austria, Vienna, and then you go further. Okay. So I explain again. I think I can't explain anymore. We need to go forward. So guys, we have now to use the read shape poly function, yeah, from the map tools to assign that path to an object, like yesterday. Now we check what is in. What is in? Can somebody tell me what is in? How many variables are there in? Annika, can you say how many variables do we have in these shape files which we have read? Three variables, exactly. We have 3 variables plus the whole coordinate stuff. So Zahra said she doesn't think that the problem of the Masume is to the Iranian server. So as I said, we don't use Iranian server, people. We use Austrian server. Never ever, even if you are in United States, South America, Germany, you use Austria. Nowhere else. Don't forget that. Good. So we have three variables and we have coordinates. Guys, I want to show, I will show you the magic later. The coordinates that you see here is the center of a polygon, or it could be the official administrative city. Yeah, but this is not whole things that we have in a polygon. So we assign the read shape poly. So we have read the polygons. We see we have three variables there, and we see we have a coordinates, but we have more things to it. More things come. Ready, guys? So we plot it, and we see the first special objective very plain, not fancy, but it shows polygons. Guys, the polygons is not only the center of administration. It has more points, and these are the points of the borders. This whole data are in one shapefile. So you have the border of polygons also in the shapefile. We will see them later. Good. So everybody had the plot of the Germany. Yannick, do you have the plot of Germany? Zara, do you have the plot of Germany? Mauricio, do you have the plot of Germany? Okay. So we check the class. Yeah, we check the class. Yeah, what we have a SP package, a spatial polygons data frame assigned to the SP packages. Yeah, and we can check the data. Yeah, we have three variables. One is, you see, NOTS level means NOTS 3, means a municipality. And there are codes which are in this shape. It's like DE112, DE111. A code is assigned to each one, but this is a Deutschland, so Germany, DE111, 112. So they have this shapefile is established by BKG, this organization, in this way. And you have, for example, alphabetical order, Eichenfriedberg or Ahrweiler. So these are the name of the municipalities in this file. Yeah, good. Now, as we extract the coordinates, you remember here at top list, guys. Yeah, this is the coordinates. One thing, we check the summary again. We check the summary again here. In summary, it is not written how many points we have. So we should have somewhere, I forget, we take an information to see how many observations do we have. Yeah, here in the STR data frame, 401 observation, guys. 400 observations we have. And now we extract the coordinates of 400 points. You see, this is the point. These coordinates is extracted here, people. It is a matrix. I can ask. It's a data frame. It's separate. As the way I extracted is a data frame. Look, this can directly be assigned to an Excel file, and there you can go to make the matrix. So you see, we have a matrix and we have arrays. Matrix is arrays. Yeah, STR. Again, the name. Run. Look here. It is a character. Oh, it said something wrong. It's something bad. The values we have here is character. So it is better that we convert them to numbers numerically. It is very important. We need that. We'll work to that later. So people, these coordinates we see here is in meter. We can, hello, how can I see which coordinates in which nodes codes? Oh, that's the hard question. That's the hard question. So let's see if we can answer the question of Yannick. So Yannick wants to see which code is which region. Yannick, this is a way to extract this data from that. So people, be very careful here. I put this here, names Valkyries at data. We have three things, nodes, levels, codes, yeah? Now, names, you're welcome. So here, names, we have three. So guys, we can take this one, yeah? So we take the name, for example, this name, yeah? That's, and we will assign the $sign to the data set, and we have it like that. Who has it? Who has it? You who? We have the name of the regions in this data set. Who is there? Who has this? I put it in the chat. Names extracted, yeah? Now I will make a cbind. You remember the column join. I will put the name here. Let's see if it will work. If it is not working this way, I will do some manipulation. I force it to work this way. Let's see. It didn't work in this way. So simple. So guys, when we want to assign things together as a matrix, yeah, here we have the first column. That was what should be the names, and the second and third the coordinates, yeah, but it didn't work so simple. So my advice is this. We will have first the coordinates defined as data frame, yeah, as data frame. You will work for you. So you got the names. Yannick got the names. Oh, okay. For those who didn't take the names, you can do what I'm going to present. So you define first this coordinates as a data. We'll say D1. Yeah, D1. Yeah, so D1. And then it is a data, yeah? And you will say D2 is D1 at the third. So the third variable, like name, is equal to this thing. So we assign something to that. Let's see if it will work. So data frame first, name added second. Now we write it D1. Yes. Who is there? So you see, when I put it in the chat. So first coordinates defined as a matrix, and then we add this third dimension, the third column, with this trick. $sign, very important, people. $sign is like a key thing in all. Who has it? Annika, do you have it? Annika has it. Mauricio, Alberto, Albors, Zahra. No, not names coordinate, man. Names coordinate, no. Coordinate itself. Yeah, definitely. So you don't need names coordinate. Why? Coordinate, look. Go to the coordinate. Coordinates is here. Look here. Here. Extract the coordinates. You start from there. After you, I put it in the chat. After that, you define it as a data frame and test it. You know, when you run this code, the DEU, then you run it in the console. Then you attach it to a data frame. You make it as a data frame called D1, and then you add the names to it. That's it. And D1, you can test it again. Guys, test the data you make, data frame you make. You test it in the console all the time. Now we go to the coordinates. Go look to these coordinates that we have already here. Look, these are in meter. We can make it we can change it to kilometer. Look, I divided by 1,000. It's now a kilometer. I said 1, so it means the UTM-X, and if I select 2, UTM-Y. I can divide the whole things. In old R, it was sometimes that if I want to divide something, I needed to put it in I, so I function. I put the whole coordinates matrix in an I divided by 1,000. Yeah. Look, people, now we have kilometer. We don't have a meter. So each UTM point is now based on the kilometer. People got it? Are you guys there? Divided by 1,000? You got the kilometer? Yeah, good. Now we plot the coordinates, guys. Yeah? Look to the coordinates without dividing by 1,000. You have meter here in X and Y, and you have a picture of Germany. These are the center of the municipalities. Yeah? And now we divide it by 1,000. We have that in the... So how we interpret the difference between 5,400 and 5,600. Can somebody write in chat? What is the difference between these two? This here. What's the difference between these two? What does it give it to me? What can I found with that? Anika, what does it mean? What does it mean? This stuff I've divided by 1,000 and put them in the plot. Exactly. So you can the distance between 2 points. So if the points is like this, then you have like a triangle, and you have to estimate the distance through formulation that a power to 2 equal to b power to the plus c power to 2. Yeah, so that's it. So this is working like that. So these points, they show the distance on the x and y dimensions. And then if you want to find the distance between 2 points, you have to use the formulation I said, and we will see where we will have it in the SPDEP package. So far so good? Yes. Yes, exactly. 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 So far so good? Good. So people, we go further. So we put a color. So we start with some plotting. So plotting, people, look, we put a color to it. Yeah. So I start with plot now. So plot, an old version of plotting in R. So guys, now the plot that we have, do something. Yeah. I add the color, write LWD equal to 10. Enter. Yes, the size is changed. CH 19. Ready? So PCH maybe 10. You see the shape is changing. Yes, we have it. Who is there? Ah, you are right. Annika is right. P and L. But I remember all the time we used to be managed with the numbers. But right, yeah. I have not everything in my head all the time, you know. Yeah, so that's it, guys. We're going. Yeah, it's all the time fun to play with our stuff. So PCH. We keep the PCH now. Ha. Who's there? Do everybody has A in the plot? I just put PCH 65. Yeah, you can enjoy. I put the link in the chat, and you guys can enjoy more links on the plotting. So we have it up to done. Now we go to work a bit. I think my computer has a problem. I don't know why. I will show you some changes that's happened to it. So look what I've done. I said I want to plot these things. I put the main title test, and I said cex.lab means the labels 3. Yeah, I run it and I have this. So labels become big here. Yeah, I've not written a title for label. Just do it like that. Now I do something else. I just go there and play with the label. No title this time. I didn't put in the main anything. Yeah, I didn't put in the main anything, and I just run the plot, and I got it a plot without main. Now look, I have the plot here. I just make it a bit smaller here, guys. Yeah, so I put the plot there. So now I do a magic. What I do, I will add a title. Look, I add a title here. Yes, title appeared. A layer of title added. And now I mess up with my labels on the X and Y axis. How? I add this one. So the second title, yes. I don't know why, it doesn't take the old title away from me. This is the first time I interface this problem. I think something is wrong with R here. At older time, it used to be replaced without being messy, but now it's like, guys, who has this shape with a bit messy labels on the X and Y? So Mauricio has the same problem. Yeah, so I think something has wrong in the system. Old time, it was not like that. Yeah, but I give an exercise to you people to play with plots. You will check how you get rid of the label and add the new label. This is an exercise, but you know, because we will work with ggplot, you may never use the plot anymore. Plot is an old thing, old-fashioned, out of mode, is dead. Yeah, so guys, we go to run the plots without title again. We add 2 titles and we add the grids. Yeah, we have a grid lines now. Grid lines can be changed. So the lines down that is the gray put is the grids. So we can make them thicker if we want. Yeah, so thicker lines, thicker grid lines we can do. Yeah. Yeah. So some play with the old style plotting which are dead. We will go for the new ones. So here, not bad. Maybe we do it again here. So no title, no label. We just played with the grids and the plots. So I think up to now everybody understands how the UTM work when it is plotted. So UTM, I have introduced it because it helps us to plot the geographical regions nicely, and we don't deal with the spherical face of the Earth. Yeah, so we do the histogram of the first column of the coordinates. So look down the coordinates, the x's, yeah. The x's are between 300 and 900 for Germany in the zone 32, I think. And the UTM Y, so the y-axis is between 5,200 kilometers and 6,000 kilometers. Everybody is there with histogram. Mauricio is there, Aniko is there, Yannick is there. Okay. Zara, are you there with the histogram? Alberto is there, yes. Guys, don't be sad if I don't repeat the whole names because it may not be in my head all the time. So I made the console a bit smaller here. I work more with the codes. Good. People, you can, if you use an old R console, you can divide it to 2 windows, and if you work with 2 computer monitors, then you put them in different monitors. That's the nice approach to do. So normally it's not separated, but check in the RSIC how to divide the interface of R to 2 windows that can go to 2 windows when you work with 2 monitors. Yeah. So now where we are, we have been here. So now we need to work a bit on the randomization of numbers. Yeah. So if you remember last time, I said we can make a sequence, yeah, sequence of the numbers through R. So here I make a sequence, for example, between -4 and 4 with a step of 0.01. Look to the numbers is created, a list of numbers. I can now assign a density to it. Yeah. Normal distribution with the mean 0 and variance 1. Densities. Look, guys. Yeah, I can plot it. Look, I can plot this what I've made. I can plot these densities. I made a density, so it is like a histogram that we made, a normal distribution. Yeah, I can see what I've made. So I am creating some vectors just to see. Yes, who is there? Densities for -4 to 4 created, normally distributed. Yannick, do you have it? A vector of densities. Yes, so we can check the same thing again with the hist. So we check the hist of this X sequence. So this is what we created, and then we assign a sort of normal distribution to it. Yeah. So I leave this extra things to you. Now I go to create the vectors of random numbers. Here I have prepared the uniform distribution, Poisson distribution, normal distribution for 100 observation, and each time I define the parameters of the distribution to that. Yeah. So a normal distribution, I can create a normal distribution with running Rn here. So Rn, it assigns a normal distribution nicely. Yeah, this is a normal distribution. Yeah, you can take the histogram of Rn and you have it. Yes, normally, more or less normal distribution. Yeah, we go to Poisson distribution. So let me put the histogram here. Hist Rn. Yeah, so we make a Poisson distribution with lambda parameter equal to 10 for 100 observation. You know, the Poisson distribution is the distribution which the mean value and the variance are the same. That's the lambda. You know, I'm not only agricultural economist, I'm also a statistician. So a minor in statistics. That's why I love R and this playing with the data. So you see Poisson distribution, mean and variance the same. And the uniform distribution. That's it. Uniform distribution. So I make some databases, we will use them later. FCT, okay. I wanted to teach you guys the box plot. So we have now 3 different distribution of data, which are randomly created. So if I go here and I say Rn run, you see this is a random numbers. Who has the random number now? Rn. Should be there. Annika, do you have the random number? Rn? Good. Now, Rp. You see? Poisson distribution. And Ru. Now we want to do a magic. So we assign a vector of factors. Look guys, this is FCT. 1 repeated 25 times, 2 repeated 25 times, 3 repeated 25 times, and 4 repeated 25 times. I put them together, I made a vector. Look, FCT vector. Yeah, you have it. And now I put the vectors to the data like this. Like this. I just put RU, why not? RU also. RU, I added to that. Yeah, so we have a data, and then it is 3 random variables, and the last part is a sort of a category. Yeah, which I made for myself. Uniform, Poisson, random, and a factor. You see, guys? So we can say head of DAT. We check it. Who is there? Who is there? Head of the DAT. Yannick is there. Annika is there. Yeah. And right, we go for the box plot. We say Poisson as a function of these factors. Data from DAT. Nice. We have our box plot. We can add a title to it. Main equal to box plot. Run. Box plot added as a title. The whole things we have played with them, we can now play with the box plots. Yeah. So we can add color, everything. So color, why not? Color. We call color yellow. Yeah, yellow. Then it looked like very bad. No, actually not bad. Yeah, that's good. So you learn how to deal, you will have a box plot in R. So now we want to put a bunch of things together. A bunch of things we want to put together. We will plot this RU with Poisson. Yeah, let's check if what comes out. Yeah, that's one thing should be done. We changed the, probably we need to change. Let's see what should be changed. C, X is that, LDIP type, here type is P, we just added the P, that's it. Yes, you see guys, so we have the first plot, PDF of a standard normal. No, not. We just keep the title, no problem. And now we put the normal Rn to this Poisson. And then we say we want our nice box plot at the end. So we put the box plot at the end. And then, as I have said yesterday, we put all of them together. We have 3 plots and we put them together. Yes, we go. Yeah, beautiful, yes. Who has it? People. Yannick, do you have it? Are you there? Annika is there. Albert, are you there? Are you so far? So who else from Zahra, do you have it? Oh, you know, very, very sad for that. That's yeah. So people, was it good so far with the, do you think that you are familiar now with the basic plotting? Yeah, we are still with the basic plotting. We will go to the heavy plotting soon. Happy with the basic plotting? All the codes you have, Joanna, and then this latest version I will upload again. So, people, we go back to our shapefile again. We just see the summary of the names. You see there is nothing there because it's a character. Yeah? Character has no summary. Yeah, we check the data. I think this part I have already given you. I wanted to explain how the dollar songs works. Yes, that's it. Factor. People, we have this variable here. You see, these are the codes defined. The DE as the abbreviation for Deutschland from 111 to GOP. So it is changing. These are the codes. And for example, I want to assign a number to it. How can I assign a number to a character? I have to transfer it. So first, I have to turn it to factor. Yeah. So I turn it to factor. Yeah. It is a factor now. And then I can transfer the factor to integer. And it creates random numbers to me. Nice. So guys, I have defined a new vector that's ID, and this vector is a transformation of the codes inside the shapefile as the DE something. Yeah, and I need this ID. So it is 401. So each time when you want to count the number of observation in a data set, a data object, or in a vector, you just write n row uppercase. N row uppercase. Don't forget. N row uppercase. I just put it in the chat. This is a very important function to check the data all the time. So far so good. Everybody has the ID with 401 observations. Yes, Mauricio has it. So I just do an inductive and then the rest is Albert. Yes, Yannick, yes. So guys, we need now a library of RGDAL. Yeah, please install the RGDAL. And there, we want to do magic. We want to transfer 2 points with their coordinates to UTM. So the coordinates are these. Latitude and longitude. 118 and 10, this first point. 119 and 50. These are the second points, yeah? These are 2 points in the space. I want to calculate their UTM, yeah? You just give an example here. You use the project function, you assign these two here to x and y, yeah? X and y, run, yeah? You have a matrix of numbers, and these are actually 2 points. X, not x, so longitude and latitude. And now I project them to UTM. You see zone 51. That's it. We got it. We got it in meter, people. You can transfer the UTM to latitude, longitude on other words, the different ways. And one of the ways is using the projects. Yeah. So this is a place you can read about a problem a guy had. Look, somebody has discussed that and he is just asking for more help or solutions, and people gave him more options to work with that. So if you like, you can read a bit about the UTM converting to latitude, longitude, or the other way around. So far so good. Latitude, longitude, UTM, everybody catch it? I need some yes, no, crashed, collapsed. Perfect. So did you manage to come back to R? Oh, sorry. Good. So people, we go to ggplot2. So we first establish this amazing library, and then we go to have the next level of fun. So everybody please install these two packages. Library ggplot2 and library SF. Oh, very sorry for Joanna. So at least you can follow, you know, that the codes are there, you can go through them again later. It's all fun, you can do it alone. You have a whole data set. So now you remember our shapefile? We had a shapefile somewhere up. We had defined our shapefiles when we read these codes of the BKG. So there, Wahlkreise. I put the name in because I was working before. I was looking for a nice shapefiles and I was ended in some Wahlkreis, but then I found the BKG. So you remember we read this file, this shapefile first with the function from the SF, and then we had the map of Germany in this way. Now we read the same path. So the path, you remember the path we had, we put the name SHP on it. Yeah, you see what is in this SHP. The same things look like with additional elements, the geometry. I will tell you shortly what's that. 400 observation, as you said, STR, guys, keep with me. Here we go to the fun now. So SHP has the ability to extract more information from the shapefiles, and we will go to see what it can. So now I plot the SHP, people. Right, plot SHP. Go. Boom. Yes. Can somebody says what is the difference between these three plots? Is everybody there? Is everybody has a Germany with different colors on three maps? So some fancy pictures. Mauricio has it. Muy bien, muy bien. Yeah, Mauricio has it. Albert has it. Notes 3. Yannick said notes 3 level all blue because, or exactly, that has used that code to color it. So we had the three elements variable there, and it has used what is assigned as a code and wants the name as a character to color the different municipalities. Yeah. So if now I can read the same thing with the similar function. So I used the read SF last time, and now I read it with a stRead. Yeah, another function from the same thing, and it gives exactly the same things. Yeah, so these two functions more or less works a bit similar. People, now we go to the fun. Ready? We have that ID, you know, ID, keep it. Keep the ID, we need it now. Yeah, so we go and use the ggplot. We put this SHP file from the package of SF we have extracted, and we keep this part empty. Yeah, we run it. Map of Germany on the ggplot. Who is there? map of Germany with ggplot without color and the grids. Even on a spherical shape. Who's there? Yannick is there. Okay. Albert, are you there? Do you have the ggplot there? Yes, Albert has it also. Annika said, no, the SF package is not working. Why is not working? So you cannot run it like this? Like, look. Annika, here. That's so pity if it is not working for you. It's working for everybody. Yeah. Look, library SF. Okay. Good. It's very bad that just people are kicked out because of the crash and all these problems from the list of active participants. I'm very sorry for this. Hopefully, we could. It could be much fun if we could do it in presence. So now I put the ID, guys. I put the ID into AES. Color equal to ID. Look what I have. A bit border coloring. Beautification of the same panel. Is everybody there? We're going to have a nicer map of the municipalities, the Gemeinde in Germany. Yes. Yes, mapping is going on. Now we fill it. We go for the look, people. We will now have a teaching on the ggplot. Yeah. So don't worry if you don't know what I'm doing. We will learn it soon. And we come back to the here. I put the fill. So I said I want to fill it with the code of ID. And now I have this nice map of Germany appear from the shapefile. This is the same thing we had before. Yeah, but we use the power of the ggplot too. Yeah, never ever. If you later work with R, plotting only with ggplot too. Only with ggplot too. Yeah, that's it. That's it, Albert. ggplot has not only that, the ggplot has transferred that to a spherical face. If you see, you will see the spherical structure is given to the map by ggplot itself. So we input the UTM to it. It produce itself in the first step. You can play with that to transfer it again to UTM, but I leave it to you people to do it yourself. Yeah, you will later can work with the codes. You have the start of the track, and if you stay with this software, you can work on it and you can learn more how to play, make the maps. Imagine you make something like this, put it in your scientific production, whatever it is. How impressive that could be. You made it yourself. So as you see, here. I couldn't find how I can extract the coordinates from SHP yet. I could extract the coordinates from the shape poly before, but not from SHP. I need myself to work on it. But you can extract the data from SHP like this. Yeah, so the Gemeinde names or the municipalities is out. Is our municipality in? I don't know. I need to check. Let's check if I found ourselves. So it's like Saale. Durchsuchen. Where's the Durchsuchen? Hä? No option for search. Just search can be done only here, not there. Here you can search for that with Such finde, but that find, but not here. Good. So far so good. People ready to go for ggplotting? ggplotting ready? I mean, we had already made a map, but we need to know what is this plot structure is. Is everybody there? Ready? Albert said ready. Yes, yes, yes. Where did we combine ID with SHP? That I leave to you to find, my friend. Yeah? That is what will not be mentioned today. Yeah, some homeworks. Yeah, it's not like that I say everything here. Now we have a limited time. Look, today, now it's like almost 12. We will have 45 minutes lunch break also. So there are other stuff to be said. So adding data, yeah. So adding data to SHP and subtracting data from the SHP. These are two duties I leave to you guys for the future ggplotting, mapping, and spatial econometrics. You work on it. How you will subselect a set of the data from a shapefile and how you combine the data sets to the shapefiles. Two duties for future. Now, we use now the data available inside the ggplot to understand the major aspects of the ggplot. Look, I use MPG. Is a sort of data sets available inside the ggplot. I write it again here, MPG. Right, people, write MPG. It gives some data about the cars and petrol use and the type of cars, things in the United States. Automobile industry. Yeah, you can see the title, and then you can see what type of title is that? Character, double, integer, and class, highway, city, drive, things like that. So now the first things. People, remember the plot, how it was working? In ggplot, it works differently. So you put the data first, and AES, the area that is like the structure of data defined. Dispel and highway, yeah? So if you run only this part, you get nothing. Yeah, an empty plot. Yeah, that's what you get. But then you add the layer of points. Display relation to highways. Yes. The first teaching of, so in ggplot we have the layer issue, so we need to add layers after layers to things. Yeah, now I add a color, but I want each point to have a different color. So if it is the point, yeah, I work like this. I take one of the variables inside, look, one of the variables inside, for example here, the variable of class. The variable of class, which one is the variable of class? Is here, yeah? So we have compacts and twister, mid-size, minivan, pickup, and subcompacts, yeah? And then it will assign the color to it automatically. Look. And don't forget, we are inside EES. So when we want to assign different colors to different points, we need to stay inside the AES. We can do further. We can change the shape back to the point and change the size. So I add two more variables, a vector of variable from this data set, yeah, to the size and shape inside AES, and then I finish it. If I run this again, I get nothing. Yeah, look, guys, I get nothing. Yeah, empty space. Yeah, but if I add a level of point to it, I will get it. Nice. And you see we have a sort of label defined on the side. Who is there? First ggplot training. Yannick, do you have it? Do you have these beautiful shapes of the cars and drives and highways? And Yannick has it. Zahra, do you have it? Mauricio, I don't have MPG data set. It's impossible. It is a part of ggplot. You should have, if you have a ggplot 2 installed, you should have an MPG. Look, something is wrong probably. But you have achieved the map. Mauricio, you have achieved the map. We were working with the ggplot 2. How come that you have worked there? Yeah, but that was with ggplot 2. So it means that ggplot is fully installed on your computer. So this data, this MPG, check it. MPG is a part of the ggplot package. Look, I didn't take it from anywhere. So do something else. Write the next data set. Write diamonds. Write diamonds. Write diamonds in the console here. Do you take this data set? Yeah. But don't worry, follow me. We will work again on the shapefile and you will catch up a part of the missing things. So just you have the codes. You have the codes and you can work on it. So we go to diamonds, the next data set. You see we have some data, a relation between some quality and the price of the diamond. Yeah, and then here we check it. Yeah, we have it. Price and carat diamond. So the higher quality, higher price. The old things we made can be done here again. Yeah. So a character can be assigned, for example, clarity. So I will add it clarity here. I take a clarity here, guys, and add it to a color as a class. Clarity and the color as a class. We just check it, what comes out. Click here. Yes, that's it. You see different categories of quality classes. And you have the label. Not fascinating how these plots work? So you can define the category of the color of the points. You need only to have a right data sets. You start with the nice plotting. We go soon to work with the plots and to define how we just change the structure of this in the way that we want that for our publication, commercial or scientific. Yeah. So we made a clarity. Oh, now we go back to another data example. We go for economics. This is a time series, people. Time series and date, unemployment as a function of dates. Not a function, so just changing through the time. We can change the color and size as we have discussed before, but we do it a bit differently here. So if I put the color differently into the line, look, I will have a different color here. Size, I want to change the size. I don't like this size, I want the thick one. So thick one, I added a size to that. So did you get the point? If you want each point of the observation has different colors, or back to the category renting, you go to the AES and you put the color and size there. But if you want the uniquely to have the same color or same size for all points, you put it inside the second layer, which is, for example, point or line. Yeah? And now we test the histogram, my friend. So the same thing, we take one of the variables, not two. Look, MPG, we take CTY. CTY with MPG, we check what is that. Look here, CTY. Just make it a bit okay. CTY. No, MPG. MPG. CTY. So it has a different values, you see? Cities, actually. So now I run the histogram. Yes, histogram in a ggplot structure. Everybody is here. Everybody is with the histogram. Yannick is with histogram. Annika is with it. Albert is with histogram. Who else? Mauricio is collapsed. Annika is Annika, you are there? You have it, the histogram? Yeah, I think Annika is completely collapsed now. Good. So guys, we do further. Now we just go back to the MPG again, and now we check something. There is something strange. I notice that when I put the colors itself here, it gave me all the time the same color. Look. That was not expected. So I put green, it gives me something like red. Guys, do you take green here? Guys, do you have green? Is it green or is it red like me? So I wrote green as a color, I got red. Yannick has a red. Strange. And then when I put the blue, look the next one. I had a blue. That's strange, man. So you know, not everything is under control. Sometimes R starts to think itself to do some stuff. So be ready to challenge this issue. Oh, there is an error happens here. Ah, that's AAS. Okay, I got it. Here we need 1 point only. So I just increase a bit the size. Nice, big one. So guys, it's just fun to play with the data. You can have this whole cheat sheet of the colors in R in your head and then work on it. We just go for the cheat sheet of the colors. Cheat sheet. Yeah. Yeah. So too much works, people. Yeah. So different colors and can be defined in different ways in R. So R has a very strong coloring power that you people can use in your research. And let me see if I can find the cheat sheets of the R's. I'm not finding that now. There's like a long list of the old colors and codes. You just need to have that cheat sheet, and then you go after that. Cheat sheets, colors in R. I think it should found it. No, not yet. Ah, here. So some comparison is given, but still not the codes. I know that there are some places that we can find the codes. Somehow it's out of my colors and colors function. Ah, here is that's it. I think we have it now. Yeah, PAL, unclean CO, unclean colors, and then with some numbers that is given here. So works to do, people. If you want to play with the colors, the options is there. Yeah. So this guy has used the color 12. I don't know which one is that. Palettes. Yeah. So the same way as me, you can have a hand of all colors you can define for our possibilities of colors. Yeah. Yeah, is it? No. Yeah, so the R6 sometimes doesn't give you the exact things also you want. You need to search for it. Good. So where we are here. Okay, now we want to add some features to our plotting. I have prepared some stuff for you guys, but I will write it here slowly for you, and you just can implement it with the codes you have in hand, and we will be somehow fast with that. So we select one of the plots that we have in hand. So I will say we select the diamond. Yeah, we select the diamond here. I go down to that. Yeah, this was the example I gave. The question that Yannick has asked me, and as an exercise, I have actually written it here at the bottom. Good. So you start here with the diamonds. Then, so guys, do you know how you can get rid of the colors inside the palette? Look. I have added theme plus BWD. Yeah. I write it in chat, add it to the diamond plot. So with and without this. So each time we tested with and without. So Control C, Control V, with and without. So with, we have, look, the difference. With the inside grid as a gray, and then I add and empty the inside and it get rid of that. Yeah, so normally you don't need that gray area inside. So each time, as I said, is a layer added. So it can go to the next line. When we don't want to make it so messy, we can like it like this. So we add each time as a new line here. Working. People, do you know how to save the files? Save the files. For example, I have run this and I want to keep it. Yeah, I full screen it. Does everybody has this full screen without the gray background? Yannick, do you have it on the screen? On my screen? That's it. So, can somebody tell me how to save this file for the publication? Write it in the chat, if you know. Export it, right? Here, speichern als, it means save as, yeah? I can have different options, 100% GPF or PDF or meta files, all of them possible. There are other possibilities in our studio. You can find that there pictures are saved already there in the like short-term memory when you are working with that. So if I want to save it, I save it now. I put it in our course today, map Germany. I put it here as a first graph made. Yeah. So now let me see what is here. Now we go to next level of the working with our I want to add labels here. Yeah, I don't like those labels. I want to add two more labels. And just check, we had here price and carat. Yeah. So I will write quality and price in dollar. Yeah. So I will add this layer here. Labels as a new layer. X, I will say carat quality. And then on Y, price in USD. Now, here we go. Yes, we have it. Price uppercase, carat uppercase. Yeah, so add it to the chat. Now, the first step, I want to limit maybe a bit my space. Yeah, I want to add something to it. I want to have some negative value. Who cares? I want a negative value. So here I have it up to the 5, and there I have up to 10, 15,000, 20,000. I want to increase the limit a bit. Yeah. So X and Y both. So Y, who cares? I want to add the limit. So plus here, save limit. For X limit, I will add 0 to like, no, why 0? I will add -2 to 7, and for y I add minus 10,000 to 25,000. 1, 2, 3. Yes, 2 limits added. Check. No error is given, and probably we have it. Yes. No, we don't. Yes, we will not. We have not receive any 0. Oh, sure, we have. So look, people, we have this here 0, a negative part added to the chart. Look, negative part added to the chart. Look, here is negative part, and then we got a space over there. Yeah. Please add the next layer. I put it in the chat. So now I want to have a title. Yeah, I don't have any title. I would like to have a title. Yeah, who can stop me from having a title? And I put a title with its function. I will say Marburg NaDiMa. Yeah, and I can put it in 2 lines. Marburg NaDiMa. Yeah, and magic happens now. Look, people, we have a Marburg NaDiMa as a title. Should appear. Yes, is there top. Look. Now I will add a size to this. Size to the title. Yeah, I like it to be bigger. Yeah. You see, people, it is like layer after layer in ggplot. You just add layers to the layers to plot things. Yeah, we have it now. Bigger, yeah, you see? I just put these things in the chat, then so the limits added plus the title and plus the size. Now we just do some beautification with the title. Yeah, we want to beautify the title a bit. So increasing the title and giving an angle to y and x. So I just want to do some titling things on the layers after layers. So I will, the first part, the text of the size, the axis of the x, axis of the y, and the color of the axes. So this coding now is just going for the axis. So first, axis x, titles changed. No, this one, the caret quality become bigger. Yeah. Now, then y, I want to axis y, I want to do some beautification and given an angle. Yeah, price in USD. You know, I needed to give an angle, so I can change the angle. So imagine I change the angle to 150. Look what comes out. Ha! 50. Goes up. Yeah, so 90 is the good thing to have. So we will have a 90. We have a proper type structure. Yes. Now we do some coloring of the of these two labels. No, now we change the text of the ggplot. Look what happened to the x-axis. I increased the fonts of the elements, and now I will add more to it. Both one. Yes, people, look what we have. So this whole set now is joining the chat. So you should see from which part you need to be added. Guys, do some plotting now. Enjoy it. We want to go to the next stage of plotting. Guys, do you enjoy the abilities of R, or is boring? Happy that you like it. Yes, data visualization is amazing. With R, it's like all fun. So I thought today let's do less formula things. We just start with a good bunch of time focusing on our plotting abilities, and this helps us to understand those maps and the spatial stuff better. Even I think this is my impression from this area of science. So we do a bit more plotting. If guys, if you agree, we do like more 15 minutes on the ggplotting issues, and then we go for 45 minutes lunch. Is it good? So 15 minutes more and then 45 minutes lunch break. Like 15 to 1. If people agree, Albert is agree, Fiona is agree. Yannick is good. Good. Massimo is agree. So, people, don't be worried for those who have a crashed system and everything. This whole new setting of file will be uploaded again in the same place, and you can download it and enjoy it. So no worry, no lost. Things are there. So we want to add a subtitle. Yeah, subtitle. Yeah, imagine this whole amazing things we had is not enough. We just go to do some subtitling. So we add the first subtitle as a lab. So you see team, LAB, they are like the words, the language of the ggplot. Yeah. So this is adding layer to layer. So now we go for the subtitle. You see, we have it under the Marburg NaDiMa. We have the sub. So you can have not only the title, but you have a subtitle. Now, subtitle is here, and now we do some beautification adjustments of the title and subtitle. What will we do? We get rid of this terrible position that we have. We bring it a bit to center. A centerization. Yeah? Yes, sub left on the left. Marburg, NaDiMa, italically move to that. You see what I've done? H just 0.5. That's the point that has worked here. So we can play a bit with this character here to see what it will give us. Like, look. Yeah, 0.1. You know how it works? Look to the x axis. The 0.5 is the last point that I decide that the title will stand. So if I say I want the title to be standing at 0.25, it will reposition it again. Look. Yeah, it moves there. So I have decided that to be a 0.5. Last point. Yeah, so you can decide to go to different points. So that's it. Title made here. And then we move the sub also. Yeah, why sub should be in that such a bad position? We move the subtitle also to the right position. We change the color and size, and that's it. So here again, let's see. Yeah, italic 0.5, last point. It's done. So when you want to position the title, yeah, this 0.5 is not a standard. It's like it's something based on the x-axis. Well, let me check. Something here is strange. We have the diamonds, and I noticed something. The primary chart we had a bit change in the x-axis. That's happened out of my control. And then we had this happened. That is amazing. Something has gone wrong. No, I think nothing has gone wrong. I got the point. No. People, this edge adjust, I was wrong. It is not done with the arrangement to the x-axis. It is a standard. So 1 means end of the line, and 0 means beginning. You know, it's like too much codes. I have not everything in my head. So you need a huge memory to have codes all the time there in your head. Yeah, you see, 1 is the end, and the x-axis is not actually the scale for defining the position of the title. The position of the title is the standard between 0 and 1, and then you decide where to adjust it. Sorry for not being so accurate on all aspects of these codes. So we do now a final beautiful photo that we, not photo, so a graph that we want to make. I put the whole codes now in the chat, and you guys can anytime later play with it and improve. For example, you can search in the RSIC how to change the label. Yeah, that's something that you can do. Or we can add a label, somehow an idea. We will add a legend. What do you think? We add a legend now. Legend we had, no, we add a footnote. We add a footnote. Let me find where I made the footnotes for these things. I had somewhere defined the footnote. Oh, I don't find the footnotes. Oh, caption. Ah, yeah, that's it, caption. That's it. A minute, I will put the caption there. Let's see if it will work. Yes, guys, we have it down. So I write now here source 2 point ggplot2. Yeah, and should we do something more interesting with the caption? Let me see if more things can be added. Yeah, that I found. So yes, so we can add more things. We can add some formats to the plot, to the caption. For example, we can say we want the big one in red. So let's see if it will give us it will be given to us. Yeah. Yeah, we have it. We have it. We have that. So this whole set of codes now on the diamond data, I give it to the chat for those who want to do some playing with that. So please be careful. Each time after a plus there is a enter, the next line starts, and everything is following. So I think this is a good beginning with the abilities of ggplot2. I have used some help from my older graphs now to be faster and to make it somehow a sort of visualize for you people. I hope you're not angry with that. I use some hands from old time. But yeah, that was the option to be faster. The ggplot2 is a book. I have introduced that yesterday. You guys can check, and there you can see the visions and the power of that. So now I do something. I pick up these abilities I had added a bit to my plots, and I go to our mappings. Yeah, I go to here to our mappings, ggplot. I see if we can make a better German map. So we had this one the last time we made the German map. So now we want to get rid of this gray background. So what we will do, we will say we don't want it, plus yes, the gray background is out. ID, if you remember, I made it. ID, I made it from the German ID is DE something, and I just changed it and made this new one. So now let's see if we want to maybe make a bigger area. So I will put it between 4 degree and 17 degree E. No, like we play a bit with the elements of the title. We just put a title, yeah. Why not a title? So we put a title and we call it German map. We have it. As you see, the old problem is now up to the left, and we just adjust it with what I have provided there, not for the subtitle, for the title. So we add that to this, and we test it now. Yes, German map in the middle. How nice is that? Yeah, so why not we add some labels to latitudes and longitudes? We mention it. Yeah, labels to X and Y I would like to have now. So I will add a label there. Label. So I will tell X, I will say longitude. Longitude. Hopefully not wrongly written. Make it sure that the grammar is correct. No, it was like wrong. Yes. And I go there, add it there, and latitudes. Latitude. So, codes added there. Go up, view there. Yes, latitude, longitude, guys, added. Yeah, and now we give some size, some formats to the side, and yes, we have it. The title should be bigger to show to be really a title, so I put a big number there, and that's it. Yes. Who has it? No, maybe not yet because I have written the codes. So people, we will continue from this point. I put these codes also in the chat. Now is 12:47. So I write it now 12:47. So people, please go to the Google Drive and go to Spatial Econometrics and the example for SPDEP. Go there and download what is called the Spatial Weight Matrix 0. Please download this file and upload it to the R. So we are ready to go with that file. SPDEP weight matrix. So everybody has it. Run the necessary maps. So please here consider, I just stop sharing there, and I share my screen. So friends, please tell me if you have my aura screen. Mauricio, do you have my aura screen? Marzia has it, Mauricio has it, Masuma has it. Okay, so then we have it. So people, that data from yesterday from Iran province, you should have saved that in exercise, the exercise. You remember, please go and upload the data to the R in the way I taught you yesterday. So let me see, where was that moment here? Yeah, so here, look, there should be, the data should be here with Iran. Yeah, that should be the provinces and Shahristan. Yeah, that should be that. So it should be in the data should be in the example 3.1 Iran map, but we need those data. So please upload the data, put it in the path. We had it also yesterday. So I run the provincial data and I put it in the pulley path province, Iran path province. Who has the plot already? Mauricio, do you have the plot of Iran provinces? Marzi, do you have it? Masum, do you have it? Yannick, do you have it? Please be careful, guys. You have to have the path, the correct path where the data are saved. The data should be there somewhere like this, and then you have to do a forward slashing. Yeah, forward slashing. Yeah, copy here. For example, imagine the data are here, and then you go to the codes, and then you put it there. Here, forward slash. Here, like for forward slash, and then you put in the quotation, and then you should have it. So Albert has it, Yannick has it. Nobody else has it. Annika, do you have it? Joanna, do you have it? Mauricio has it. Annika has it. Good. So I just inductively say that everybody has it. So we check the data inside the plot. Yeah, we have those staff. This Iranian shapefile is a bit richer than the German shapefile for reasons which I don't know. And now we have our ggplot.sf installed from the last file, and we put our provincial data path into the SHP, yeah, and we plot that. As you see, we have many plots of Iran, because this database has different things in its area, and some ID seems to be similar. For any reason, Zanjan province is yellow in one pack. So area definitely is one variable which is there, and the bigger the area, the more yellow it is, the way that the shapefile present our files. So now we check how many observations do we have. It should be 51. Look, n row, I check 51. So I assign a random variable, R norm. You remember I have presented before, R norm with 0 mean and 10 as the standard deviation to the eye. I can put a 1 to 50 also. So I just put 1 to 50. Both is possible. And now we have a look at our ggplot of Iran. Wow. So ggplot of Iran. Anybody there? Yannick, do you have it? Annika, do you have it? Albert, do you have it? Mauricio, do you have it? Masum, do you have it? Marzi, do you have it? Annika has it. Annika said one question, is the code uploaded? Yes, it should be in the Iran map. Oh, I know where I have uploaded. It is county and province in the main file, yeah? There are county and there is provinces. So you have to download this from there and put to the directory in the exercise 1. So provinces, you people look here, you go to Spatial Econometrics in provinces. The R codes also uploaded, Annika, the R codes are uploaded in this place. Look, a special weight matrix R. There, you have to download it. I think they should be the same codes as I have it. Yeah, Annika has it. So that's it. The codes is there. And now we go. So I didn't see any fellow friend from Iran to say that they have the ggplot map of Iran. Hey, what's going on there in Iran? Is every Iranian partners out? Massa has the plot. So one person has it. And anybody else? Albert, do you have it? Albert has it? Albert was also, I don't know if Albert is still available on the chat list or not. I cannot see the participants now because I shared the screen. Good, so Masa said she has it, so I think that some people has it in Iran. So then we put the ID to it as the case of the German map, and you see then we have, yes, we have for Iran also different borders, back to the ID we put, and we can have a different colors. Yeah? Yeah. The colors can change if we change the ID. So if ID become a random variable, as I defined before, and I put the colors now with this new ID, then both of them are different shapes. Yes. So everybody has this new beautiful colorful map of the shapefiles of Iran in SF package with ggplot. Mauricio has it. Perfect. Perfect. Yannick, do you have it? Albert, do you have it? Okay. So the data is in your system. Now we extract the coordinates again. Yeah, we extract the coordinates. Look at the plots. You see a picture of Iran. Master said, what does the spectrum reveal? I don't get the question. A spectrum reveal. Which spectrum? You mean in this colorful map? This one? Here you mean? A spectrum reveal. I really don't get the question. Maybe write it a bit easier. It is the borders of the, you mean the borders of the provinces. It's the border of the provinces here. Colors is only I assign a number into the ggplot that we have studied in the last hour. Yeah. So I just fill the province with the color to just simply separate them. That's it. So I have a different numbers. I have 51 observations, which is provinces, and I assigned this fill. Look here, this is it. This is it. You see the ggplot SHV plus GOM SF AES fill ID? Exactly, just to differentiate the provinces. I can do it with the borders like this here. Look here, the borders. I put different colors to the borders of the polygon. So each polygon in this case is a province of Iran. But Iran has 31 provinces. They have somehow treated the islands and some cities and regions separately. So that's it. But the goal is this. We have islands in the south and the provinces. Yes, that's it. I just make it beautiful and just put a color in it. No other reason. Here, yeah. More question? If not, we go to plotting. So we have these numbers, you remember last time, and as we have learned, we can put a a 1,000 meter out, so like this, yeah. So something strange happened. I put 1,000 and then I just reached some negative UTMs. That's strange. If somebody can say why we have a negative UTM here, a technical question. Because it's a standard, so you can put, you know, UTMs are having different numbers. Exactly, exactly. Mr. Kuhi, exactly, different zones. Well done, well done. So now we define the nearest points. As yesterday, we defined 15 neighbors first. Yeah, we check the neighborhood. You remember, people, I need once again go to my picture to repeat an important issue. I leave the R, upload the file, and say it. Don't forget, people, we are going after the neighborhood and then we establish the weight matrix. This is very important. This is what is the target. Without a good weight matrix, we have not any possibility to do the spatial analysis, spatial econometrics. I mean, you can do GIS, you don't care about it. So, again, we go back to R. So, Mr. Kui, do you have my R screen? Yannick, do you have our screen? Okay, good. So, good people. And now we defined again the k-nearest points with k-near. Yeah, we run it, and then we have, look what we have in this data set. This data set is based on what we have defined as 15. You see, we have defined a 15, and this is simply give us a 15, an idea of the 15 somehow observations near to the to each observation. Yeah, the way that defined the weight matrix last time. This is the coordinates that we have in UTM, and now we define an ID, the 52, and we assign it to KNN, k-nearest point, to neighbor. This is the function, people. Very important. I have said it thousands of times because it's important to me. So now we go further. So we define the codes. We defined the neighborhood, and we can see what is inside what we have defined. So call weight is the neighborhood. We are not still on the weight. Yeah, it is written weight here, but it's not. It is the neighborhood. So we have a 675 links defined, and the average number of links per observation is 15, as you remember. Yes. So we plot it. Yeah, this is a shape. This can also be beautified if somebody wants. Yeah, you can put. I made it a bit here. This can also be an issue of beautification if we want, and we want it now. Yeah, who can stop us? So we want that, and we just replace these two variables there. Yeah, you can pick it up from down. I put it now also in title. We don't need, just leave the title out. Yeah, so we put some grid lines now, and now we check it. Yes, UTMs on meter, and a sort of picture of Iran, weight matrix for each center of provinces, 15. So now we just play a bit with this scale. We just put it on 10 to see if we will receive the same beautiful weight matrix. I mean, it seems that 15 is working. So we go to code on 5. Let's check the 5. Let's check the 5. What is the with 5? Still everything is connected. So we go to 3. K-nearest point, 3. And still 3 is work. 3 is work. So 1. I just want 1. Will the 1 is will work? No, 1 will not work. 2. Will 2 work? And you see we have an island. Here, people, look. On this side, we have an island. You see? In the southeast, we have an island. So 2 is impossible. But 3, maybe. We make it 3. Okay? Maybe 4. Maybe 4. Just subjectively, I decide on 4. Let's see what comes up. Seems okay. Yeah, so if nobody has an objection, we keep the 4. And you know, guys, you see, when we keep the 4, the center east desert is look like nothing is in. So it's like not affecting anybody. And that's objectively is right. So I take the 4. Yeah, And now I go and put it in the grid lines to see more or less where are the UTMs. Okay, that works. And let's see, this is the same thing up to this point. And now as the thing that worked wrongly yesterday, I found the error in the codes. I assigned now this neighborhood with the coordinates, which are based on UTM, to a variable x. Yeah, I list them. So we need to somehow do a delistation. So check what is this xxx. XXX. Yeah, this is a delistation. So we have 51 point, yeah, and we have a delistation of the UTMs. Fascinating. And we have, for each point we have 4. You see in the R console? You see in the R console? So I just check with everybody if we are connected. Yannick, do you see the console of the delistation of the UTMs? Albert sees. Okay, when Albert sees it, means it is there. Now, Yannick said yes. Okay, now we use the NB2 list weight, which I have discussed about. Assign it to new variable. We defined the style means weight. W is the weight matrix, yeah, and we come up with our weight matrix. We check what is here inside this. Yeah, you cannot simply see this friend here. We just do a bit of exploration with Colquhoun 11. Yes, that's it. So, and a string, it shows us a sort of relation between the IDs and weights. So you see, people, these are the weights, and now we are going to see how the weight matrix look like. What we have to use is the list to math. So list weight to math is the thing that transfer our weight matrix to an acceptable matrix. So in order to see it better, I full screen my R. So I clean the space here, and people ready? We go to see the weight matrix. Yes. That's it. That's it. So, guys, you know what we have now in hand? Can somebody of us from Iran says what each row means? I'm looking to the chat. Someone from Iran says what each rows mean. So, the rows of the matrix, not the column, the rows. Yeah, you see here, you have this value, you have this value, and you have these values here. What does they mean? Remember, I said in the theoretical part, I said if you sum them up, you reach to 1. Yes, we can test it. We can really test it. We can see if we sum them up, we reach to 1. Yeah, because this is a matrix, we can sum them up. Here, we go there. That's it. This is a matrix. I call it MM, a matrix. I run it here. I just need to do that first. And now, people ready. We make the matrix MM. Yeah. And then I will say now, MM, I want the first row only. Look, I need this sign. First row, look. First row means the effect of other points from the other 50 observations on ID number 1, which I've assigned myself to that. And if I do a sum here, I say sum, I have 1. Guys, got it? Any question on our nice nearest point weight matrix? Did you feel how matrix works in R? So I have made a matrix, and then nicely, this is a matrix, yeah? This is the rows and columns, a symmetric one, yeah? And the weights are assigned like that. So if 11 is here, it should be there also. Look here, the same value to the 1. No, it's not so symmetric. Interesting. Like some changes has happened. No, if you remember, it shouldn't be symmetric. We have discussed the neighborhood defined symmetrically, but the weights are different. Yeah, we have discussed that in the session. There was one of you has asked me the question on. So any question here on nearest point? If no, we go to D nearest point. You see how fun is that to work with R? Even matrix algebra. So no question, then we move to another function. We can find the longest distance in between 2 points now in our data set. Longest distance between 2 points. So we delisted it. Here we can use this function. We use the call weights, the neighborhood, the coordinates, and latitude, longitude false because we use the UTMs. And then we run this, and we just somehow we get the distances. This is the distances between 2 points, each 2 by 2 points defined by us, and we can use the maximum to find what is the maximum distance between 2 points. It is in our data 528 kilometers. The 2 nearest point, the nearest. It should be somewhere probably around the desert in Central Europe. Question here? If not, we go to the next step, and that we deal with the next way to with the D nearest point. So it was a C nearest point the first round, and now we will deal with the D nearest point. Let me find it. Started here. So D nearest point, people, careful. We start to find again our nice neighborhood with coordinates. Very crowded. So we just reduce it. Not 900,000 meters. We just go with 9 meters. So that's not good. That doesn't work. So we go to 15. It means 150 kilometers we define, and we check it here. No, 150 kilometers is not good. We need more. We need maybe 300 kilometer distance. How's it that? Still not. We have islands here at on the eastern side, in the Sistan, Balochistan and Khorasan. So we need more. So we need to go to 400 kilometer. I am not sure we will reach to a value in this system. That's it. The problem is only, I think Zahedan in the southeast has only a connection to the Kerman, which is logical. I mean, center to center of province. I think we can deal with that. So we have one point of this area that only affects another point, but we can deal with that. People, don't forget, you can go and look after the other ways of finding the neighborhood, the contiguity, the rook or queen ways, yeah? But what I am teaching here, because it's more useful for the microdata, I am teaching the d nearest point and k nearest point. And don't forget, you don't need these UTMs to be from a shape file. You can find only those as the data, put it in a database with other data you have, and come here. Shape file is not necessary. Don't forget. So everybody is here. People, did you manage to come up this point? Do you have this fantastic weight matrix with the d nearest points at the area of 400 kilometer? Yes, Mauricio has, Yannick has. Who else has? Iran. I need some people from Iran. It says Mahsa has. Okay, good. Anika has. Good. So the nearest point managed, and from there we do again, we need to do some delisting, again delisting, you see. Again, we first made the neighborhood, we plot the neighborhood, and now delisting to see that each point, how far it is from the other points, which are in that diameter of the distance. And now it's time for weight matrixing. So let's see. I have done some changes in the codes. Hopefully it's not affecting my weight matrixing. It's also good, so we can go further together. So unlisting done. Yes, this is a list of the distance between the points. Yeah. So we have now like 654 relations, and this is distance between them. Yeah, too much talking. So now we define the weight matrix. So people, don't forget, I have done some delisting, and I have to use the latest one, which is corresponding to this weight matrix. So I take this weight matrix, people, like, look, this is this is a k nearest points, yeah, if you remember. So we need this. This is a d nearest points, excuse me, d nearest points, and we have delisted things. So we have to take the right delisting. Let me see where it is. Unlisting. Yeah, that's it. So I have to use this probably. Let's check if I'm right. So I think this should be the case. Let's see if no error given. Oh, error is given. So something is wrong in my system. I have to find where is the delisting. Delist. I think this should be that. But I need go shortly here up. Is it right? Coal weight. Is it coal weight what we made? No, we didn't make a coal weight. We made this. So I just put it shortly here to see if this is right. Yes, that's it. So we have delisted. Yeah, so we save this one for this new structure of data, the nearest points, and then we put delist into the neighbor to weight matrix. People, this is very important. Neighbor to weight. Yeah, so we have made the neighborhood. We move to weight now. So that's it. Yes, we have it. We have it. Yeah, you see, I check the class of the neighborhood and list is in this weight matrix. I just extract the weights, you know. You can use your weights. You extract the weights. This is the weights we have given, but in very messy things. Now we will see it again by the list to math. List to math. That's it. We have the matrix again, and we will test this matrix. I put a W on it. W. So this is exactly a weight is a matrix. We have it on the PowerPoint last week. So I open it up, people, again, check, look, W. This is a weight matrix. The nearest point. Yeah, things are not based on the 4 nearest anymore. Look, we have different ways as depending on how far or how close our 2 points are to each other. Yeah, again, weight matrix. If I say W 1 comma nothing empty, then I have the first row. If I write here 51, I have the 51st row. Yeah, I don't know exactly which region is that, but this is the way I made the weight matrix anyway. So sum, it should end up to which value? Somebody write it in the chat. I want to see if everybody is not sleeping. What should be the result of this sum W? People, 1, exactly. That's it. We have it. So people, any question on the small sample? We want to go to the county level to test it there. Who is in with me? If there is no question on the nearest point, we go to the same thing. We will test it. We will test it with the county data. Any question up to this point? I hope everybody is understand how I could visualize the nearest point, the nearest point, and the weight matrix for each of them. I have tried my best to be as simple as I could. Good. So when there is nothing here, I just write this weight because we will now check it with the counties in Iran to remember that we have tested our weight matrix. So let's see what are some extra things here what we don't need. So this was for finding the maximum point. So maximum point, people don't worry, I upload these codes again as a final version. You can, if you are not so secure, you can have an access to that. So here it is, everything is written, nearest point, the nearest point. So you have the notes and you can work with it later, hopefully, and you can establish your weight matrices. The weight matrix is in this issue is the most important thing, as we saw in the theory part. These things down you really don't need. I will later delete it because we have already our nearest point and the nearest point. You're like some other stuff I added. So ready, we go for the now. It is 2:17. And I will do we will test one more weight matrix with our county data. People ready. County data. The path should change. Path should go to the county. So please check which place in your computer you have the data for the path, and we go there. Yeah, I run it here. Yeah, you have to check the path. Please check the path and find the data and forward the slash if they write the wrong correction, wrong sign is there, and then we have the path for the counties. Run. That's it. We have it. And now we go for the shapefile. Yeah. As usual, we check the plot. Yeah. We have more data, as you see. We have around 300 something polygons. I don't see it in this area, but we can check it. The names, as you see there are some strange. R is not still adapted to the Middle Eastern languages. So in the shapefile, you have Persian language in, and R cannot read it. So guys, be careful. Read the RSIC if there are possibilities somewhere to touch some settings to have non-Latin languages appear to R. It's also Russian, Chinese, Japanese. So there are possibilities. I was not interfacing till now and didn't work on it, but you can. So we have the shape files uploaded, and we run again. We make sure that we have ggplot SF. So province will change now to path for the county. So people, please change the province to county there. Maybe deactivate the province files information. Yeah, so now we run the SP and we plot it. We will have again many data. Yeah, then data at the county level. I have to confess, I just pick up this shapefile from somewhere in the internet. So it seems that it has a problem because Iran has not 300 something counties. It's 400 something, but this shapefile has somehow neglected some counties. Yeah, but it's good for our job. So it can help us to establish our weight matrices. The only thing, as you know, again, I insist that the only thing we need is the coordinates. So this done, we checked the data here. What do we have here inside the data? So we use the str, a string, to see what is given. So 337. This is the number of counties they have accounted for in their shapefiles, which is wrong, definitely. It cannot be less than 400. But it helps us, so we don't care. And yeah, heads, we check the heads. Yeah, in the heads, you know, head, as you see, when you put the head, you see what are they in the data set. So there are some names, and we have the area, as you remember. So area we have as a factor, as a variable. Now, what we will do, we do that part. We read it with SF, as you remember. We read it in the SF. And now, because we have 300, how much I said? 337, we have to change somehow our ID making. 337. So, okay, we select first the non-randomized number, and then we assign it. Ready? We go. Nice. That didn't work. Something went wrong. Ah, that's it. I should put the county, I put the province. What I said to you guys, I done a mistake myself. So here, now, read, and ID defined. And now we go for it. Yes, Iran's map, shapefile just downloaded from somewhere nowhere in internet, nicely appeared on ggplot2. 337 observation. We go to weight matrix now. First some IDing and some coloring, some good things on that. Yes, so let's see how it looks like with the color. Yes, people. I put the ID in the AES. Don't forget, I taught it in the before the lunch, yeah? AES, not in the ggplot part. I put it in the GEOMSF AES. So it means each observation needs a different color. Yeah. So we change the ID structure from 1 to 337 to a random file. So hist ID. So we check how it look like. Yeah, nice. A random file defined. I taught you how you. That's why I just said this randomization data making in R, because I wanted to use it at this stage. So yeah, now somehow we have more because the ID is different, then the colors defined differently. Yes, you see. Yeah, a spectrum, as Mahsa asked, is now only an ID defined by me, assigned as a color to each county. And we can distinguish between different counties. So biggest counties, as you see, are in the desert area of Central and the East. So the county is big, but nobody is living there. And the counties which are in more mountainous area, northern area, they are more populated or smaller. Any question up to this point? We want to go to make the weight matrix for our beautiful map. Not a country, it's a county. So some people have said something. Mauricio, do you have a question? Is everybody here? Is everybody here with me? Is everybody have? Mauricio, do you have this nice map on ggplot? Mauricio has it. Yannick, do you have it? Master, do you have it? Annika, do you have it? Nice. Nice. So I hope nobody accused me of the discrimination. I divided the time equally, more or less, between mapping and ggplotting between Iran and Germany. So no accusation is accepted. Now, we have the data assigned as Iran. So we have to make it sure Iran is a county this time. So Iran is a county here in the shapefile. Yeah, I just take the province out to be sure, and I run it again here. Yes, I have the number of observations will be checked now in Iran here. NROW Iran 337. Yeah, so things are okay. We go to the coordinates and we plot the coordinates. Now we have a more because we have county centers here. Yeah, then we have a shape of a country more obvious, and we do some plot beautification. Yes, coordinates, you see here I divided, so we are dealing with kilometer, not the meters anymore. And now we will see how many co-nearest points we need. Co-nearest points. ID assigned. And co-nearest point defined. And now we need to define the neighborhood based on the 4 points. Not bad. No island. Everything is connected. So we have a global weight matrix working. How about the tree? So make it 3. Still, I think 2 will not work. Let's see. 2. Do we achieve an island? Yes, you see in the southeast in System Balochistan, we had a problem. So it is disconnected from the whole setting. We need to return it back. So with 3 nearest point, again, we check the plot. Yeah, makes sense. But maybe, you know, when you deal with the geographical things, check the r6.org and then look at the way that you can define the rook and the queen way. So only polygons which have a border connectivity. But as I said, you may deal with the microdata. So that's why I deal with the NN, KNN and the DNN. So some beautification. We checked that. Okay, nice. So it seems that we don't have, we have critical points that 1, 2 points, they have only not many neighbors, but it's okay. So we go further. We go further. We sort the IDs, sort people. Sort can sort the vectors. So if I say that, it's like this, cbind, make it a column and put it down. Now, so from co-nearest point to the neighborhood, I think we have done it, no? Yes, we have done the co-nearest points to the neighborhoods. That's what we've done. Now we go for the weight matrix here. Yes, so weight matrix, things as before. Yeah, things as before, only more observations. I define the MMM. So we just check it. We just check it. Why not? So we just maybe I assign this weight matrix to M. So least weight to mathematical structure. This is the function, the way the function defined. So people, we do some matrixing again. So MM. Yeah, we check it. It's too much, you know, our crashes. But I think we can understand what R wants to tell us. So look here, observation 1. Its relation to observation 268, 78. So here we don't see any weight assigned. So these are far away points from what we need. So here 19. So we do some matrixing. Yeah, we do some matrixings. And we go here, we say MM, row 1, comma. Wow. We have some nearest point people. So 3 nearest point as we defined. And as before, if we put some here, we have to reach to 0, to 1. Yes. So I can go for observation 300. I see the same thing. So what is the 300? How is the relation between observation 300 and the rest of the observations in a row structure? Yeah. There are 3 points and different weights is assigned correctly. Any question on the co-nearest points? Weight matrix. Oh, distance. What is the furthest distance between two counties here? And the maximum distance defined in this case is 236 kilometers. So imagine that there are cases in Iran that two cities which are not the center of the things. It's like in Germany we say the Gemeinde. So they are 236 kilometers from each other. There is no city between them. Huge thing. So, questions on the nearest points, Iran map at the county level. We have managed the weight matrix, which can be used for the modern eye test, which can be used for the spatial regression, everything. I don't see any question in the chat, so we go for the last part, and that is the weighting. So let's start for the nearest point. We define 40,000 meters, the first one. ID is the same class as you see. We are in the class of the neighborhood. You see NB. The class, the type of data we have now in hand is the neighborhood. So people, we check it directly. Terrible. 40 kilometers doesn't work. If you remember, we shouldn't be less than 230, I think. So we start with 200 directly. So let's see if 200 works. Yes, 200 worked. Everything is somehow sort of connected. It seems that. So these connections appears in the east all the time. So what about 180 kilometers? Ah, 180 it worked. 150. Ah, 150 didn't work. So So we start from 150, we go to 160, we check the map, it still doesn't work. 170 kilometers, the least distance. Yeah, so I'm not very happy with the way that the south is defined. Near to be an island. The real southeast is near to be an island. So I just, from my stomach, I add like 10 kilometers more to see if I reach to something better. Yeah, I'm happy with this one. So, any objection about the way I have defined the nearest point? Nobody is unhappy, nobody is happy. Some critics on me. No? No question in chat. We go further. So, again, with delisting, people, very important. Delisting, we find the maximum distance available now in this case with this nearest point. Oh, we reduce, people, 198. So when we use the distance, the longest distance between 2 points is 179 kilometers, almost 180. And the least distance between 2 points, we can check it here. So it's too low. So we use the head of the same variable. We check it at here. We do it. This is the head. That's definitely, that should be like that. This is the maximum we define. So we have to go to the list of the unlisted distances. Here we see what is the, so 59 kilometers. It's very logical. You can find many places in Iran that cities are are less than 100 kilometers from each other. So in our shaping file, the least distance between two centers of the counties is 59 or almost 60 kilometers. Any objection to this data? Yeah, so far so good it seems. So we do the delisting again, and now we go to do the weighting matrix. Yeah, so neighborhood to weight. People weighted neighborhood to weight. Delisting. We do the summary again, the same as the city. We come to the weight, and that's it. We have our weight. Again, we check what we have. Yeah, you see, then the structure is completely different here. Now we have a sort of weight defined based on the distance of the points from each other. So there should be some points they have many neighbors, that there should be some points they have less neighbors. So we go there, 1. Yeah, here, different to the nearest point, point 1 has now many neighbors, and weight is differently assigned to each point. 2, different. 300. Less. It should be somewhere in that southeast or something like that. So, any question on the weighting people? Weighting matrix, weighting people? I want to close this chapter now. I hope you guys enjoy. Those guys who are angry say no. Those who are happy say yes. I want to see if you're connected still. Annika is happy. Yannick is happy. Albert is happy. Big yes. So means Albert is very happy. Mauricio is happy. That's it. The rest are unhappy. I got it. So, people, this is the weighting. And now we go to the last part which I designed. Professor Farzanagan is happy. Very good. So, weight matrix done. We go to do one. Now is we do 10 minutes probably. One more regression, and then I think we should be at the final part of the course. So friends, I wanted to do 2 regressions, but I think we will keep it in one. The same thing from yesterday, we review it once again and to see how the weight matrix works. So please, those guys who have not downloaded, they have to go to the Google Drive again here. And this one example, a spatial regression. That's what we need. And you should have downloaded the shapefiles. If the shapefiles are not downloaded, and if they are not here, I just upload the shapefiles. It seems that I have not uploaded the shapefiles here. So I upload the files. People, these are the 3 files that I upload now, and you please download and put it beside the place that you have the files of R codes for this regression. So please download these 3 shape files and be ready for the last part. Console empty. Regression open. We go to see if we can rock it now. So, libraries well installed. File people don't forget, we should here, I just opened it. We should now read the shape files, yeah, of somewhere in Chicago. So, This is my path, but you people, you have only this foreclosure shape. That's what you have at the end. So I just run it. Oh, mistake has happened. Something is wrong with me. So what is wrong with me? Let's find it. Not here. I should be there. I should find the path myself correctly. So this is the path for me. These are the files. So I should have this path exactly. Let's see why it's not working. Yeah, I have written something else as what I should have been written. So example here, you see, it said the potter fell in the pottery. In Persian we say the potter is the kuzegar dar kuze uftad. So I just made a mistake myself. Now we read that. Hopefully this time, yes, we have it. Shapefile with some data assigned to it that we will use for a regression is there. And we check again the polygons. Yeah, we can do all those things again here if you like. So we just shortly use our weight matrix from last file, and we just check the ggplots on the plotting. So people, we do some plotting with the Chicago data to criticize the quality of their data, maybe. So I just brought that to our plotting staff here. That's it, to have a feeling how the data is. So we read this with read SFE. Now, not that one. We read now this time chai poly. We read the chai poly. So I want to see if everybody with me here. Let's see. Error happens. Why? Chai poly, we should have it now here. That's it. We have that. And the string plot. That's it. And we should be able to read it by this file, but it gives an error somehow. Is it because of the library? I think library we have already installed. We had already the ggplot SF installed, so it gives us a problem, some vector problem. Yeah, so no problem, we leave it. So we cannot do a critics on the graphing issues, unfortunately. It doesn't come with us, but at least we have the data. So we have the poly, so we know that the Chicago area, and then we do some pricing checking with our spatial regression. So I just go after coordinates, and I go after the coordinates. So where are the coordinates? Here, I just saved them somewhere. Here. So we start from the simple regression. We use the look, people. We have discussed that when we want to extract the data from the shapefile, it should be with at data. So chai poly at data has extracted whatever is there in the database. We can check the names. Yeah, we can check the names if we see which variables are in. So names, again, check it there. So we have these variables as data available in this shapefile, and we will use some of them now to do a regression. So violence as a function of unemployment and ISTFAC. ISTFAC, I don't know what's that, but just we go. So all else run, linear model, we check the summary. What do we have? We have a sort of Unemployment is not a significant variable here, but this East facts rate is significant, highly significant. 31% R square. Now, poly to neighbor. Remember here we have a bit of development. So here we use the poly to neighbor. So this one goes directly from neighborhood to the weight, and important things here. The neighborhood here defined based on the queens. Don't forget the chess on Monday. Yeah, queens, not the rook, the queens. So we run it. We have the neighborhood. Yeah, let's plot the neighborhood. Let's plot the neighborhood. Yeah, we just plot it. Oh, mistakes given. Queen true plot is something is missing here. That our plot of the weight matrix, what we have done with Iran data, is not coming. Here, the coordinates, people, that's it. That's why it didn't come. So we need first to define the coordinates. So check the coordinates. Yes, we have it on latitude and longitude. Now, we go first to the weight directly. So we go to the weight and we define the weight. So weight matrix, people, remember, weight to math. Yeah, we can do some mathing here again. That's a function from our weight stuff. Weight to math. So let's see if this works here. So we put our weight there and we run it. Yes, MM. You know, we have a mathematical structure of the Chicago's weight matrix. That's it. Again, if we say MM row 1, then we can find who is affecting one, who based on the rook. That M didn't work. So sort of, we have the weight matrix, we have 110 observations. Yes. But we cannot take it in the first row. So let's check the, oh, you know why? Because I put a 0 here. Yes, people, that's it, that we have it. That's it, we have it. Now, sum. We take the sum of the weights and then we will see. So what should be the sum of the Chicago's first row of the weight? If anybody not sleeping, answer me fast. Oh, Yannick has asked a question. Is the spatial data frame but path quantity is only the path? Yes, that is the problem. Yes, you're right. I think you're right. You know, I'm like my brain is not working anymore. So people, one, as Yannick said, we have it. We have it. Yes. So we put the coordinate weights in this case. And we take it. So that was the rook way, yeah? So also nearest, the nearest point they have used to develop the weight matrix. Yeah, we can test it. But I think we are happy with our rook way of the weight matrix. So we go directly to our Moran I test. So we have the error term of the OLS, people. We put it in the Moran I test and two-sided. We can have one-sided, yeah? but we do it a two-sided, and it's like exactly like the normal test, yeah, one-sided, two-sided. A student test, one-sided, two-sided. So OLS shows a highly significant p-values, means our OLS is bullshit. So we need to go for some regressings. So the SPD package has an interesting element. So I do it again here and explain it what it gives. So it tests which model is better to the other one. So we have somehow we can check different models. So Lagrange multiplier for different models, and we can see what we should go after. So it seems that from this package of the test it has given us is a comparison between different models. I am going for the first one. Error is significant, and the first lag is also significant. Both are significant. So we can test both in this case. So don't forget, this is a way inside the SPDEP package you can test the results. And as Yannick has presented today in the morning, you will run the spatial regression model. You will see, you see here, the R score increased. Rho is significant. You see, remember that Iranian paper and compare it to this rho. Yeah, so a lag regressor, the first spatial lag regressor, heavily significant. It's 50%. So it is a really a special model. So it means that OLS doesn't work here. But there, in the paper in the morning, I am sure that OLS and SAR or SEM, all of them, they will give you the same coefficients. So the first model we have gone, as Yannick said, you can do it with the system, with instruments, so 2 SLS, and rho is a bit different here. So I will leave it to you to decide between 2 SLS and the maximum likelihood estimation in the first model that we have in this build, which one is the best. I will say, now without any testing, I will say the maximum likelihood is the better choice. But I will not tell you why I come to such a conclusion. I'll leave it to you. So, we leave the impacts. People, the coefficients of the spatial model, yeah, as I said yesterday also, it should be somehow manipulated to show the direct effect of the x on the epsilon. Epsilon, I say, y. Yeah, x on the y, the effect is not direct. So the two x variable, two regressors that we have, they have a different effects on the dependent variable in this case. And that is not the coefficient in the models we have. Look to the coefficients in the SLS and to the maximum likelihood. That you cannot directly interpret. That is not a marginal effect on the x on the y, but the impact, which is a sort of marginal effect. So impact is the marginal effect. People, don't forget. So we go to the error term. Yeah, we do it. SEM. We run it here. We check our rho. Rho, significant, 50%. No, excuse me, not rho. Rho was in the SAR. So SEM, spatial error model, lambda, 50%. Again, this model, I think this model at the end should be really what in the Iranian paper in the morning I showed you. So they have to use the Kelly-Khan-Perusha model, probably. that they come up with the right model. So this need both, I think. Then probably the final error term is free of the noise, is free of the correlation, and moral I test will not show any. So people, don't forget, after you run the regression, you can have again the residuals extracted, tested with the moral I test. Yeah, residual extracted from the model, the same as linear models, and then tested again with the moral I test, as we have seen here. So we go back to the moral I test here. Yeah, the moral I test, instead of a model, you can put here, not the model. Yeah, you don't need to put a model. You can put a vector in that place, and then it gives you again the test and will say if that is variable. So when we put the model here, it takes the residuals, but we can put any vector there. Yeah, and as a final regression we run the feasible GLS to test the error term here. Again, we have a lambda reduced, still near to 50%, and yeah. So all signs tell me that this model probably cannot be only managed with SEM and SAR, but it needs a Kelly-Khan-Purusha approach. So people, this is it.